Okay, so in this part, we are going to discuss some more questions which are related to the topic groups and logic. So here we are basically preparing for the entry test. So in the previous videos, first we have discussed some tables which are being used in these questions. Then we discussed some of the questions, and this is the part 3. Here we are going to talk about some more questions. Okay, now the question is, the truth value of this statement, okay, this is the statement, is false when. All right, now obviously we will be using multiple tables, right? So first of all, since the main sign is implies, let's just quickly go to the imply table and see when this table can be false. Okay, so I did not read the question. Let me read the question first. The truth value of the statement this is false when. Now we need to see when the implied statement is false in the table. Okay, so we need the imply table. All right, so this is the imply table, and here it is false. It is false when the first statement is true and the other statement is false, right? Only then it is false. All right. So far we know that for this part should be false and first part should be true. All right. So we are clear with that part. All right. So here we need to have Q false and all this true, right? So first let's just cancel out all those examples, all those options, sorry, which are saying that Q is true. So clearly B cannot be the answer because like it is saying Q is true. If Q is true, the statement cannot be false. And again, C cannot be the choice because Q is true. Let's talk about A option now. All right, now in A option, Q is false, right? We are clear with this part. We only need to have the first part true. For having the first part true, let's see if P is true. Would that give us this thing true or not? All right. So for this, we have P imply Q intersection P. Right now, obviously here we need to focus on this part, on the, I'm saying it intersection because if I convert this logical statement to sets, this is intersection, right? But here let's call it and, okay? So let's just talk about this table. Let's see when this is true. So yeah, so it is true over here. Like this is the table. Here we have the sign, here we have and sign, and it is true when both these are true, right? So it is true when both these are true. All right, so we are clear with that part now. So for having this statement true, we need to have P true and we need to have this part true. Okay, perfect. So P is true, right? Again, this part is true. We need to have this whole statement true, and P is true, and we need to have P implies Q true as well. But let's see if it is true or not, right? All right, so I'll use a different color now. We are working on P implies Q, where we know that P is true and Q is false. Simply, we are very close to our answer. We need to go to the table only. We need to go to the imply table and see what is happening when P is true. This is basically the second one. Here P is true and Q is false. So it is going to be false, right? It is going to be false. P implies Q would be false. So, all right. So P implies Q is basically false, right? So since it is false, so this whole statement would be false, right? And for this statement to be false, we wanted it to be true and this to be false. So yes, Q was false in this part, but with P true, this is coming false. This part is coming false. However, we need it true. This means that A cannot be the choice again. So D is the answer. So apparently these questions are tricky. You would not understand them immediately, but you only need to have, you know, the idea about these tables. If these tables are at your tips, you need to draw this table like these tables quickly, because obviously in your NET, you would have multiple questions which would be related to this topic, right? So every question would basically require the use of these tables. So you will not be drawing these tables for one question only, but for multiple questions, right? So only then you would get right answers. All right, so we are done with the fourth question. Now we have the fifth question, which says the inverse of A arrow B, right? Again, we have to use the table, like not the table, but yes, some definitions, which I have also shared here. So the inverse of this part is this part, right? If we had P before arrow, we again have P before arrow. If we had Q after arrow, we again have Q after arrow, but we have minus signs here, okay? So the different thing here is minus sign. So A arrow B, the inverse of A imply B would be minus A implies minus B. So this would be the answer, right? Okay, now let's talk about the sixth question. All right, again, the contrapositive of minus B imply minus A is. All right, contrapositive, right? We need to look at the contrapositive. Here it is. So the contrapositive of minus B imply minus A is A implies B, right? Like obviously here we have Q and P. In the question we had minus P implies minus A. This would be A implies B. Okay, let's look at the question again. Here's the question. So for minus B minus A, we have A implies B, because like the contrapositive of this statement is actually this, right? So again, if we have this statement, the contrapositive of this statement would be this. Okay, so A is the answer. All right. Now we have converse. Again, if we look at that, at those informations which we have for converse, it says that basically the converse is P arrow Q is Q arrow P, right? So we only have to shift the statements. For P implies Q, we have Q implies P. So for this, we are going to have minus A implies minus B, right? So D would be the answer, right? Because again, if we have a look at the definition of converse, here it is. The only difference is that if we had P here, it's here now. If we had Q after arrow, now it's before arrow, right? So yeah, so we are done with that question as well. Now let's talk about the eighth question. Okay, now here we are talking about groups. Okay, let's just talk about group first. All right, now think of a set S, right? And the set S is going to be a group if it is closed with respect to the binary operation, if it has associative binary operation, if it contains identity element and inverse for each element. Okay, so I did not write down everything because obviously the aim of these videos is just to solve the question. Again, if you are interested in all the content and all of that, you need to register for our live classes, which are online as well. All right, so okay, so we are saying that this would be group, this set is going to be group, and we have some conditions, right? We need to have the identity element, we need to have the inverse for every element, and it should be closed, right? Okay, now obviously if we talk about addition, here I am going to get, like if I basically use the operation plus, I will get 1 plus minus 1, that is 0. So this is my identity element, right? In case of addition. Why? Because like whenever I add the additive inverse to the element, I get 0. And I do not have 0 in this group. So clearly A cannot be the answer, right? Let's think of B. B is multiplication. The multiplicative inverse or the multiplicative identity is basically 1, right? So we do have 1. So we are clear with the identity. I repeat, in A we had plus and A was not the answer because we do not have 0. If we had 0, yes, then this could have been the answer because like we had the identity. But then obviously we have to check if we have inverse elements and stuff like that. Okay, so A is not the answer. If I talk about B, it is multiply and the multiplicative identity is 1. So I have that. Now I need to have inverses as well, right? So the multiplicative inverse of 1 is 1, right? Like if I multiply 1 with 1, I am going to get 1. That is the identity. For minus 1 itself is the multiplicative inverse because again I get the multiplicative identity. If I talk about iota, minus iota is its multiplicative inverse because I get minus iota square. That is basically minus into minus 1, which is 1, right? So I do have my multiplicative identity. I do have multiplicative inverses for every element. And yes, this group is closed with respect to multiplication because if I multiply 1 with minus 1, I get minus 1, which I have in this group. If I multiply 1 with iota, I get iota. I have iota in this group. If I multiply 1 with minus iota, I get iota. If I multiply iota with itself, I get iota squared, that is minus 1. I have minus 1 as well. If I multiply iota with minus iota, I get 1. So I have that as well. So it basically satisfying every condition for the group. So clearly B is the answer, right? It is a group with respect to multiplication. Okay. And since we are clear with multiplication, we have our answers. We do not have to check the other options. So it is a group with respect to multiplication. All right. So let's talk about the ninth question now. A semi group is monoid if, all right. Now if I talk about the definition of monoid, it basically should be closed with respect to the binary operation. Again, it should be associative and it should contain the identity element, right? So it a semi group is going to be monoid. And if I talk about semi group, so it is closed with respect to the binary operation and it satisfies the associative property, right? So semi group is closed and it has the associative property, right? And the only thing which we need to have it is basically the associative property. The only thing which is different in case of monoid is it is also closed, it also has associative property, and it should have identity as well, right? So a semi group is monoid if for monoid we need it should be closed, it should have associative property, and it should also have identity. Semi group already is closed, it already has associative property, only it does not have identity. So if it has identity, it would be a monoid as well. So A is the answer. Perfect. Okay. Let's talk about the 10th question now. Okay, so 10th question says, which of the following is not monoid with respect to addition? For monoid, it should satisfy the associative property, the binary operation should be closed, and we should have the identity element, right? So far, we have been discussing so many questions that by now we know that natural numbers do not have 0, right? So if natural numbers do not have 0, it clearly means that we do not have the additive identity. So C is the answer, right? For a monoid, it should be closed, it should satisfy the associative property, and it should have the identity element as well. Addition means additive identity. So clearly, in natural numbers, the set of natural numbers begins with 1, 2, so on. We do not have 0, we do not have negative integers. Since we do not have 0, which is the additive identity, so natural numbers, the set of natural numbers is not a monoid, right? So C is the answer. Okay. Let's talk about the 11th question now. The order of the group A plus is, okay, now we need to know the order. If this is the group A, right? In group A, we have 0, 1, 2, 3. Okay, so it looks like we have all the positive integers with 0. And order of the group basically is the number of elements in this group, right? So Again, this group does not have 4 elements. Like, it does have more than 3, right? It has 0, 1, 2, 3. It has more than 4. We do see these dots, so it means that it is going to have infinite many elements. So clearly 4, 3, 8 cannot be the choices. So D is the answer, because like order of a group is basically the number of elements we have in that group. And these 3 dots are basically shown for continuity, which means that we are going to have infinite many elements, right? Now, if I talk about the 12th question, now this is important. Which of the following operations is not commutative, right? So commutative means that x steric y equals y steric x, right? Okay, so if I talk about 2xy, like A option, if I do y static x, I am going to get 2yx. And I know that 2xy is basically equal to 2yx, right? So um, this binary operation is commutative, right? So A cannot be the answer because we're finding not. If I talk about B option, we have plus here. I know that even if I do y static x, I am going to get y plus x. Since x is commutative, this is also commutative. So B cannot be the choice. If I talk about C option, so if I find y static x, I am going to get 2y. Now it is not necessary that 2x equals 2y. Like, it can be possible if both x and y are same, but obviously, majorly this is not true. So this is not the commutative property. So C is the answer, right? We have to find commutative, and this is the commutative rule. So whenever you come across such a question, you just have to check for y static x, just know their answers and just see if 2xy and 2yx would be equal, if x plus y and y plus x would be equal, since multiplication and addition is already commutative. So obviously, in exam, you will not be doing it in this detail, because like addition and multiplication are commutative. So A and B would be commutative. Here we are finding not commutative, right? So we check for other options, right? Like C, which is not commutative. Okay, now we have the 13th question, which says, if x star y is 3xy, then the identity element with respect to static is okay. Now this is my question. I need to have the identity element, right? So basically, identity element is such that whenever I'll do it. Whenever I'm multiplying x with the identity element, I get x directly, right? So in this case, I am going to get 3xe, and actually I should get x directly, right? So that is only possible if my identity element is 1 by 3. Because if I plug in 1 by 3 instead of e, I would get x directly, right? So here B would be the answer. I repeat, for identity element, you should know that x into e and e into x, right? Like x binary operation e and e binary operation x are going to give you x, right? And if we apply the definition of static, which has been given, we are going to get 3xe. We want x, so e should be 1 by 3, because 3 and 3 would be cancelled, and only then I will get x only, right? So this is the answer in my case. All right, so we are done with the 13th question as well. Let's talk about the 14th question now. All right. Which of the following is not a group with respect to multiplication? Okay. Now here we are talking about the group, right? So we need to have all the inverses, and we need to have the identity element as well, and it should be closed and associative property, right? This is what a group has. It should satisfy the associative property. It should be closed. We should have identity elements and inverses, right? Okay. So 1, 2, 3, 4. All right. Now multiplication basically satisfies associative property, and uh, it is always closed. But the problem comes with
inverse. If I talk about Z, I have minus integers, like I have negative integers, let's say -3, -2, -1, 0. Then I have positive integers, so on. And for a group, I should have the identity as well. By identity, I mean if 2 is my element, I should have another element such that when I multiply it, I get my multiplicative identity, that is 1. I do have my multiplicative identity, but I do not have 1 by 2. Since in integers, we do not have fractions. So this means that I do not have the multiplicative inverse of 2, that is 1 by 2. So in general, Z is not a group with respect to multiplication, because I will not be having the inverses, I will not be having fractions. And for integers, we need to have fractions, because only then we are going to get our multiplicative identity, that is 1, right? So we are done with all these questions.